4-5, angle bisector and perpendicular bisector. A perpendicular bisector is a line that cuts another line in half and creates a 90-degree angle. So if this was my line, and let's say the halfway mark is here, this line cuts it in half and makes a 90-degree angle. The theorem, I'm just going to read through it very quickly. If a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints of a segment. Equidistant means of equal distance or the same length. So basically, if you see this picture here, it's saying that from here to here is the same as from here to here. That's what these tick marks mean. And they make right angles. It's also saying that XA, this one here, is the same as XB, this one here. Then the converse is just saying the backwards. It's saying if these are the same, then it's a right angle. And this equals this. So if you just know this shape and you know what perpendicular bisector says, then we can really solve all these problems fairly easy. For example, number 1, find MN. So we know that MN has to be the same as NL. Therefore, MN equals 2.6. Go to number 2. BD is this one here. DC should be the same. So BD equals 12. Number 3, solve for x and find UT. We know that this equals this. So I do 3x plus 9 equals 7x minus 17. So x equals 6.5. Then I have to plug that in for UT, which is this one here. So UT is 28.5. Go to number 4. Label number 5. And solve. Go ahead and do number 6. And there you go. The next page, angle bisector is a line or array that cuts an angle in half. The theorem says if a point is on an angle bisector of an angle, then it is equidistant from the side of the angle. So, I have angle APB. CP is a bisector, cuts it in half. So a few things. This angle is the same as this angle. This line is the same as this line. So know that because I can ask you questions that are based off of the angle measurement or measurements from AC to CB. Let's look at the examples. Example 1 says to find BC. Because of the picture, we know that this is also the same. Therefore, BC equals 7.2. Number 2, I'm given stuff here. For example, the measure of EFG, this whole thing, is 50. And it's asking for the measure of EFH from here to here to here. Bisector means to cut in half. So if the whole is 50, that means that half here is 25 degrees. The measure of angle EFH equals 25 degrees. Number 3, solve for area, then plug it in. I get degrees here. We know that the degrees are the same. So I get 3a plus 20 equals 2a plus 26. You get that a equals 6. Plug it into the measure of angle JKM, which would be from J to K to M. So 3 times 6 plus 20, 18 plus 20, 38 degrees. The next one, EFG, is this whole thing here. So let's put it behind it. The whole thing is 2x plus 17. GFH, which is this one here, is just a half. That is 4x plus 3. So it says to find x, then find EFG. So, if this is half, that means that this half, remember, 2 halves are the same values. It's also 4x plus 3. So we get 4x plus 3 plus the other half equals the whole thing. And solve for x. That's what you get, so we have to plug it back in now to EFG. Which is 2x plus 17 reduce, and you can put it as a decimal, which would give you 20.67 degrees. For number 5, BD is this one here, DC is this one here, so they should be equal because this should be equal to this. So go ahead and solve number 5. You should get x equals 6. And go ahead and solve number 6, but don't forget that next you need to find SP. And there's number 6.